The last video session we have discussed our case study and then we have discussed about the boiler mountings. So today we are seeing the one of the boiler mounting called as water level indicator. Okay. So this is the main important mountings in the boiler. Okay. So what is the purpose of boiler? We discussed that we are converting water into steam. Okay. But we want to know how much amount of water is maintained inside the boilers. Okay, so if the water content is less and if you are heating, what happens? There is less usage of coal and wastage of coal takes place, fuel takes place. Okay, so that we want to maintain the proper level of water in the boiler. So that this water level indicator is fitted in the boiler as an important mountings. Okay, here there is two parts. So one is the water. So when the water is inside the boiler, it is getting heated, so that water is converted into steam. Okay, so there is a water connection where water is coming inside. Here water is there, and here there is a valve where steam is flowing. There are two openings. One is steam, another one is water. Okay, so in this water level indicator, this is a glass. This is glass. This is made of the glass. So here, when the valve is open, so this water enters into this valve and then it comes upwards. It comes upwards. Okay. So this is inside the boiler. For your understanding, we have made this. This we cannot see. In the real time, this we cannot see. Only this setup we can see. Because this is the wall of the boiler. This outside we can see. Okay. So this water is coming, enters here, and then it rises to the glass tube. So if the boiler level is here, up to this level water will be increased here. So when we see this glass tube, what happens? We can see what is the level of the boiler inside, water level inside the boiler. Suppose if the water level is lesser, immediately we can make arrangements to flow water into this boiler. So this is called as water level indicator. So here there is an steam also is there, which can be opened and then it can be made. So if there is less amount of boiler, without opening this boiler or going inside, what we can see? By seeing the outside itself, we can see what is the amount of boilers. In some cases, when this valve is closed or this water is, we don't know the exact level, this can be opened, then direct connection takes place, so that what happens is water will come here. So this is the real time in the boilers. Now, based on this, we are having a small DT based case study. Okay. We have another picture. So this is a small case study. Okay, which we are relating in our domestic purpose. So in our domestic purpose we have overhead tanks. So where we are having the motor connections at the bottom. If the floor is connected with the 3 or 4, please make the size smaller, zoom level. Okay. Suppose this water tank is available in the 3rd floor. Okay. What is the first empathy part? What will be your empathy part? The switch controls are at the bottom. Okay. The tank is on the topmost surface. Is it possible to do what is the level of the water there? No. So what we will do? We don't know there is how much amount of water in the tank. We are putting the motor and then we are making the water fall in the tank. Okay. Whether you know the water level has increased to the topmost part or downmost part, how much level we don't know. In sometimes what happens? The water will get overflow. The water will get wasted. Okay. If you want to see the water level, you have to go from the bottommost part to the topmost part. So time takes place. Whether if it is 10 floors, is it possible to climb each and every time up and down? So these are the empathy parts in the real time. How to overcome this? how to know the water level indicators, how to know what is the level of the water in the tank. Based on that principle here, we have made an automatic water level indicator with buzzer. This is the setup which is available for our domestic purpose. So here there are sensors here, which is for each level they are inserted the sensors. Okay, and then it is connected with the panel board. Okay, here there is a circuit which is available. Okay, so when the water level reaches to the topmost surface, so the sensor senses and gives an alarm to us, so that we can fix an alarm for the topmost surface or the intermediate surface or the low level. So when the water is coming to the intermediate surface, it is by using sensors we can get an alarm, so that we can understand that it is in the intermediate level. When it reaches the top surface, we can sense, we can get an alarm there, so the level of the water is high. When standing in the bottommost part, we can identify the level of the water which is available in the domestic waters. Same way, these connections are made with the motor connections, with the switches. Okay, so when the water level reaches here, automatically it senses here and makes the power switch. The switch off will take place. So the power is disconnected, so that what happens is, so the motor will be switched off. So this takes place automatically, no manually. So once you can on the motor and then you can go. What happens? The water will be falling inside this tank. When it reaches the top level, the sensor is sensed. It gives a buzzer sound, or else it directly gives a signal to the motor, so that what happens? The power is disconnected, so that the motor gets switched off. Okay. So this is the real-time applications based on our design thinking. So this can be utilized as an ideate part in our domestic purpose. Okay. Now what is the empathy part? So we know without going on the topmost part, we can identify what is the level of the water, and then each and every time you no need to go there, and you no need to wait until the water is filling in the tank. Once you can switch on the switch and you can come and you can do your work. When automatically it fills, it gives an alarm. Okay, so these empathies are overcome with the help of this ideate and the model. This is the prototype model or working model which is available in the real-time market. Okay, thank you.